Hello, let's do the New York Times Medium Sudoku for May 10th, 2024. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. So I intend these medium solves to be people who are newer to Sudoku, so as a result I do explain a lot more as I go compared to my hard solves. That's going to include terminology, so bear with me here. But we're going to go over a little bit of terminology before we get started, and then we're going to go through what my systematic method is to solving these. Okay, so first we have cells in the grid. There are 81 of them in the grid. It's a 9x9 grid of 81 cells. In the final puzzle, there will be a single digit placed in every cell, just like we have some given for us. Those are called givens, but we're also going to end up placing digits. Now, we're not going to be guessing. No guessing allowed. We're going to be logically proving every digit that we place. The reason for that is there is only one solution to the puzzle, and the intent is not to try digits and then back up if you got it wrong. The intent is to logically prove every digit that you place before you place it. Okay. Additionally, we do have rows, we have columns, and we have boxes. There are 9 of each. The boxes are denoted by these bold outlines, the cells with the more bold outlines on them. These 3x3 areas are called boxes, and digits cannot repeat in any row, column, or box. And so we end up, because there's 9 rows, there's 9 columns, there's 9 boxes, we end up with 9 of each individual digit in the whole grid. 9 times 9 is 81, so everything checks out. All right. The last bit of terminology I'm going to talk about at the beginning is we have bands. A band is just a row of 3 boxes. It's just a convenient way of talking about that structure. And then we have stacks, which is a column of 3 boxes. Now, of course, you can always, bands and stacks are essentially equivalent, just like rows and columns are essentially equivalent, because you can always just rotate the board 90 degrees and they swap. But we are looking at it in this orientation, and so we will be using row, column, band, and stack. All right. But as you can imagine, any logic you can do to a row, you can also do it to a column. Any logic you do to a band, you can also do it to a stack. Because if you just rotated the puzzle 90 degrees, they would be equivalent. Okay. Anyway, that's enough with that. Now, what is our strategy here? Well, we're going to go band by band first. We're going to go through all 3 bands in order, so we don't miss anything. We're going to be primarily looking for one thing, but then there are 2 little follow-ups that sometimes work, sometimes happen, sometimes don't, before we move on to the next band. So let's do that one by one. The first thing we're going to look for is when we have 2 out of the 3 digits in the band. Now, why do I know that every digit will appear 3 times? Well, there are 3 rows. That's one way to prove it. There are also 3 boxes. That's another way to prove it. Each row and each box will have it once. And since there's 3 of them, we'll have it 3 times. Luckily, they agree, right? If they didn't agree, then we would have issues. But they do agree about that. So when we have the digit appearing twice in the band, that significantly restricts where that third one needs to go. We know there will be a third one, and we know a lot about where it won't be. So just as an example, we do have these 2 4s in the top band here. So this 4 is saying there's no more 4s in this row, and there's no more 4s in this box. And this 4 says no more 4s in its row and no more 4s in its box. So you're always going to end up with 3 cells that could still be that digit. So these 3 cells could be the 4. Now, another way we could prove that is that this box still needs a 4. We don't know where the 4 is in the box yet. And this 4 over here says not in these 3 cells, and this 4 says not in these 3 cells, because we can't repeat in the row. So the result is the same. There's going to be a 4 in one of these 3 cells. Now, it's not any further restricted. We do want to look for further restrictions. An obvious one would be if any of these were filled with givens that were non-4s. And the other restriction would be if we had any 4s down here poking up and restricting it out of the columns. But we don't have that in this case. But we still want to remember, this is an important thing to remember, that the 4 is limited in this box or this band in general. And we're going to use what a box-centric marking. So we're going to use a corner mark. There are 2 styles of markings available in Sudoku Pad, and we utilize those the same way every time we solve. So the one in the corner is called a corner mark. The one in the center is called a center mark, very aptly named. In corner mark mode, we are going to place the 4 into the corners of these 3 cells. Now, corner marks are always going to be box-centric. They're always going to mean that within this box, this is the list of cells that 4 can go into, or whatever digit is placed. So if we're using if the digit is corner marked at all, then that is the exhaustive list of cells that digit can go in. Now we're only going to do that if we're down to 2 places in a box, and sometimes 3. Sometimes 3 being if they're all in a row or all in a column. If it was sporadic like this, we would not do that. We don't like it turning corners. We like them to all share the same row or column. Otherwise, we do not corner mark it. Okay, so we have that, and that's going to remind us that 4 was limited in that box in some way. Now, we want to hunt for any other repeated digits. What my recommendation, some people just like to look, right? Just look, see which repeat. But sometimes that can get a little busy, or you might miss something if you do that. We're trying not to miss anything. So my recommendation is to start with the box with the fewest givens in it, if there is one, in this case, this one. And just think about the 2 digits specifically, 4 and 6 in this case. And we're going to look for 4s and 6s in these 2 boxes. We already found the 4, so we don't worry about that. We're looking for a 6 in this box, 6 in this box. By intentionally looking for those digits, you're not just depending on seeing it somehow. You're going to find it. And then now that we've compared this box against these 2 boxes, we just have to compare these 2 boxes against each other. Just pick one of them. If there's one with the fewest givens, pick that one. We've got 1, 4, 7. We already know the 4 is taken care of, so just 1 and 7. There are no 1s and 7s in here, so that's it. There are no other repeated digits in this band. And then before we move on to the next band, there are 2 more things to look for. The next thing to look for is if you have a filled row within a box. So like if these 3 cells are filled, or this is almost there. If this cell was filled, then we'd have these 3 cells filled. This row would be filled in the box. And when we find something like that, I will explain what to do, but we don't see it here. And then the final thing to look for is any row or box that's down to 4 or fewer open cells. So for example, this row is down to 5 open cells. There are 4 known digits in it, and there are 5 unknown. And so that's too many. We want 4 or fewer, and we don't have that either. So since we don't have any of those, we're just going to move on to the next band. Now, in this case, this band only gave us this 1 corner marking. Sometimes you'll get a lot more out of it, and sometimes you'll just get a little bit. Sometimes you get nothing. But the point is to look for it in each band, and then after that, we'll do each stack, as you probably guessed. Okay, so we're going to start with this 9. There are no other no other 9s in the band. Now I'm going to do this 1, 2, 5, and we see that 5 is the only repeat. These 2 5s look in. This 5 looks in here. And so actually 5 is in one of these 2 cells. We'll use corner marks to remember that as well. That's the only repeated digit there. Do we have any filled box rows? No. Do we have any rows or boxes down to 4 or fewer? No, we don't. So we're going to move on. All right, we're going to start with this 1, 9. There are no 1, 9s here. Now we do this 5, 6 against here. The 5 does have a repeated digit. And this 5 looks down, and this 1 is occupying one of the spots that 5 wanted to be in. So there's only 1 cell in this entire box, in this whole 3x3 box, there's only 1 cell that can be 5. So what would happen if we put anything other than 5 in there? Like, let's say we put a 2 here. No, not 2. Let's say we put a 3 here. Seems like 3 should be possible. There's no other 3 in the row. There's no other 3 in the column. There's no other 3 in the box. But by the time you get to medium Sudokus, that's not good enough. You can't just use that property alone to start placing digits. And in general, 5 has the same thing, 6 has the same thing. So we wouldn't even know if it was a 3, 5, or 6, or even an 8. So why would we then place a 5 in this box? Well, the answer is it can't be anything other than that. If this was a 3, where would 5 appear in this box? Because the rules aren't just, hey, look at one individual cell and hyper-focus on it. The rules are that the box needs one of each digit. Well, if it needs one of each digit, that means it needs a 5. Where am I putting the 5 in this box? Well, I'm not allowed to repeat it in this column. I'm not allowed to repeat it in this row. I'm not allowed to repeat it in this row. And I can't put more than 1 digit in a cell. This has a 1, this has a 3. So I would not be able to place a 5 in the box. And since I'm not able to place a 5 in the box, I've broken the puzzle. So 3 is not allowed. In fact, the only digit allowed here is 5, because it is the only cell in the box that can be 5. So it must be 5 in order for the box to get a 5. All right. Awesome. So we got a digit. We got our first digit of the puzzle. Usually we get it in the first band, sometimes second band. Getting it only in the third band is unusual, but the puzzle will do what the puzzle does. All right. So that is also the only repeated digit in this band. We look for filled box rows. We don't have any. And we look for rows or boxes down to 4 or fewer. We do not have any. All right. So now we'll just repeat the same thing, but we're going to do it with stacks, and we're going to hope for better results on the stacks. All right. So we're starting with this 4, 6. There are no 4, 6s down here. So we do the 1, 2, and 5. And I see that both 1 and 5 repeat. So we're going to start with the 1s. I just like to start with the lowest digit, so that way I know what digits I still haven't done. So these two ones look up, this one looks in, and this 6 occupies one of the spots. So we also have what's called a hidden single. This 5 was a hidden single. This 1 is a hidden single. Hidden means that we're talking about a row, column, or box as a whole. So in this case, we're talking about as a box as a whole. So hidden means some technique that's related to, in this case, the entire box. And single means there was only one cell for a digit. So hidden single means there was only a single cell that could be 1. So we had a hidden single 1. There's a single cell that could be 1, and then in the box in this case. And so we can place that 1. Singles always let you place a digit. There's the naked single and the hidden single. Go over the naked single when we get there. So the hidden single let us place this 1. Now, we already had scanned this band, but now we have more information about it. As soon as we gain that new information about it, of placing that digit, it's very important to what's called following up on placing it. Look at the other consequence. Look at the consequences now that you've placed it. Don't wait and come back to it. Do it right away. And what we want to do is we want to look for consequences in things that we've already scanned and moved on from. So we already scanned this band, and this 1 has consequences for the band. The first thing we looked for was duplicate digits, 2 in the band. Now there are 2 1s in this band. There weren't before, but now there are. And so now we can corner mark the 1s up here. So we get more corner marks out of that. Did it fill up a box row? It did not. Did it cause a row or box to be 4 or fewer? It did not. And so that's all we have to follow up on there. We also have these 2 5s looking up. There are no 5s over here to help. So 5 just ends up in one of these 3. Nothing to follow up with corner marks like that. If you found pointing, you could follow up on it, but we haven't gone over pointing yet, and I will as soon as we find any. Okay, so that is the repeated digits for the column. We're looking for filled box columns. We do not have any filled box columns. We're looking for any columns or boxes down to 4 or fewer. Why am I suddenly saying columns? It's because we're doing stacks now. It's like we rotated the grid 90 degrees, right? And I just replaced row with column. So this column is down to 4 or fewer. So the first thing I want you to do is think about what are the 4 digits that are left to place in this column. Just think about it, right? It's not the 1, 2, right? So it's going to be the 3, 6, 7, 8. And you're looking around, you're looking for 3s, 6s, 7s, and 8s. And I'm seeing quite a few. First thing I'm seeing is that this cell sees a 6 and a 7. And in fact, I'm seeing something better. So let's do this first. I'm seeing that this 6, I noticed this 6 in the box, right? It means that these 2 cells can't be 6. So we're already down to 2 cells in the column that could be 6. And then I'm looking and I'm seeing that this cell also is not allowed to be 6. So there's only 1 cell in this entire column that is allowed to be 6. And so that cell must be 6. That is a hidden single in the column. Remember, we had this hidden single and this hidden single in the box. The column works the same way. The column must have a 6, and it can't be anywhere except this 1 cell here. So that cell will be a 6. It must be a 6. We can place it. Now, that 6, remember what we were following up on was we were doing this column because it was down to 4 or fewer. But now we have a buddy for the 6. We need to backtrack and redo this stack, knowing that these 6s look down. This 6 looks in. This is not 6. We can place a hidden single 6 in this box. Now try to keep in your head, like, what am I following up on? Because you have to follow up on follow-ups on follow-ups sometimes. So this 6 here now has a buddy here, and that puts a 6 in one of these 2. It did not fill up a box row. It did not cause a row or box to be 4 or fewer. Same, it did not fill up a box column. It didn't cause a column or box to be 4 or fewer, but we still have this column here. It's down to 3 digits now. What are the 3 digits? They are the 3, 7, 8. So I'm seeing this cell can't be 3, and I'm seeing this cell can't be 7. So we don't have any more singles, no naked singles, no hidden singles. And so what we're going to do is we're going to we want to use a notation method to remember what we just found in this restricted column. So we're going to use center notations, and I'm going to fill in 3, 7, 8. And what the center notation is it's saying this is a cell-centric notation. This specific cell in the final solution to the puzzle will have a 3, 7, or 8 filled into it. I don't know which one yet, but it's going to be a 3, a 7, or an 8. We call that the list of candidates, the candidate values for the cell. And we're trying to whittle down those candidates over time. Now, this already we know can't be 7. There's a 7 in the row. So actually we can remove the center mark for 7. And this one can't be 3, so we're going to remove the center mark for 3. And ultimately what this means is that in the final solution, this is going to be a 7 or 8, this will be a 3, 7, or 8, and this will be a 3 or 8. And that will finish the 3, 7, 8 that are needed for this column, because we can't repeat any digits. So one of them will be 3, one of them will be 7, one of them will be 8. We don't know which is which. However, we do know this one won't be 3. And so actually, the 3 is going to be in one of these two cells here. The consequence of that is that the rest of the box can't be 3. And this is called claiming. It's very similar to pointing, which we haven't gone over yet. This is, I think, the first time I've gone over claiming before pointing, which is interesting. But anyway, it's a very similar concept regardless. In this column, we need a 3, and these are the only two cells left that can be 3. So one of them will be 3. We don't know which. But whichever one ends up 3, that will also be the 3 in this box, because they share a box. If this is a 3, it'll be the 3 for the box. If this is 3, it'll be the 3 for the box. Which means the box can't have a 3 in any of the other cells. And so we can actually corner mark that, because corner marks, remember, were box-centric only. We don't use corner marks for rows or columns. But in this case, because of claiming, the column has claimed the 3 from the rest of the box, and these corner mark 3s will help us remember that none of these can actually be 3. So we should not consider 3 when considering the values for these cells, because the 3 is over here. Okay, perfect. So that was that column, and that's why we focus on columns that are 4 or fewer. They often have really interesting things to find in them, like singles, like claiming. Okay. I think that is it for that stack. Yeah, I don't see anything else. Okay. Oh, sorry. We do have this filled box column. So let me say what to look for at least, but you're not going to find anything in this stack. What we want to do is we want to look in the 2 columns and the 2 boxes that aren't the filled one. So we want to look over here. And we want to look for any digits that aren't already placed in the box. So the 1 and 6 don't count. Empty cells, we don't know what's in there. These 5s, we already have a 5 in the box. So there was nothing to do. But if we did find anything, we'd be able to do more marking, or maybe possibly find singles. All right, we're going to move on to the next stack. We're almost done with stacks, and we haven't found a whole lot, to be honest, but that sometimes happens. All right, so we got the 5 and the 6 in this box, so we're going to use the duplicated 5s here. There's a 5 in one of these 2 cells. No duplicated 6, and then the 3 and the 8 also not duplicated here. So no other buddies. Surprisingly little to find here. There are no filled box columns. There are no columns or boxes down to 4 or fewer. So we're going to move on to the last stack here. So I'm going to start with this 9. It has this buddy 9. Those look down. And that does place 9 as a hidden single in this box. And when we do that, that removed one of my 6 corner marks, because this cell can't be 6 anymore because it's a 9. And so if it can't be 6 anymore, now there's only 1 place left in the box for 6. My corner mark is telling me that. And once you get used to scanning that, that'll scream to you. It'll be like, hey, look at me, because there's only 1 corner mark 6 left in this box. And so we can actually place that as a hidden single as well. That tells us it's a hidden single 6 in the box. All right, so that was the 9. We also have the 2 and the 8. So we do have these 2 8s looking down. This 8 looks in. So we can place this 8. I should note that we should have followed up on this band. Let's place this 8 first, though. I feel like that's lower hanging fruit. So we can place this 8. And then we do have this buddy 8 looking in. That lets us place this 8. Okay, we got a lot to follow up on now, so let's just make sure we cover all of it. So we did fill up this box row. So we want to look at these cells for anything that's not placed in the box already. We don't care about any of these. 6 is placed, 9 is placed, 5 is placed, 6 is placed. So nothing helpful there. We reduced this box down to 3 digits. We want to think about what those are. We need the 1, 2, and 4. Now I'm noticing this 2 up here. Now by saying 1, 2, 4, we're looking for 1s, 2s, and 4s all around. And I see we have this 2 looking down. So that does place this 2. We can follow up with a buddy. Following up with the buddies is always nice just to do right away. So we can do that. And now we have 2 digits left in this box. It is the 1 and the 4. We don't have anything helping with that, so we just put 1, 4. But this creates what's called a naked pair. Naked is a prefix we use when we're talking about the candidate list for cells, so the center marks. So it's a very cell-centric idea of naked. Remember, hidden was using an entire row, column, or box. Naked is using specific cells. And usually they involve specific cells that share a row, column, or box. So in this case, this cell is down to a 1 or 4 only, and this cell is down to 1 or 4 only. They can't be the same digit as each other. They can't both be 1. They can't both be 4. So the result is that one of them will be 1 and one of them will be 4. The question I want to ask is, does this cell care which order these resolve in? Does this cell care if this is 1, 4 like this or 4, 1 like this? And the answer is no, it does not care. That's why I'm asking the question. It does not care. It's going to see a 1 and a 4 regardless. However this resolves, they're in the same column as each other. So the 1 and 4 are going to end up down here. So the 1 and 4 can't be up here. That's the important bit. So this corner mark 1, 4, I can remove that. We also know this cell can't be 1 or 4. I don't think there's anything immediate to do with that, though. So we're not going to worry about it quite yet. We will do it in a moment. But by removing that corner mark 1, 4, what I've done is I've reduced the 1 and 4 in this box to the same 2 cells as each other. When you have overlapping corner marks like that, that signifies that you may have a hidden pair, hidden triple, something like that. The only other restriction you need to look for is that the number of digits that are restricted is equal to the number of cells that they're overlapping in. They have to be exact overlaps. And when I say exact overlaps, I just mean that there aren't other cells in the box that those could go in, right? So I've identified these 2 cells, and these 2 cells completely contain the 1 corner mark and the 4 corner mark for the box. So 1 will end up in one of these 2 cells, and 4 will end up in one of these 2 cells. Well, that's a hidden pair. Hidden pair meaning we can just say these cells will end up 1, 4. They won't end up anything else. So when you find something like a hidden pair, hidden techniques in general, remove other candidates from those cells. So this naked 1, 4 removed those candidates from the rest of the column. A hidden 1, 4 removes any other candidate from those cells that we found the hidden pair in. So for example, we thought this cell could be 3. There's no reason to think it couldn't be 3, except this may remind you of my explanation of the 5, except if this was 3, then we would only have 1 cell left for 1 and 4, and they'd be fighting over that cell, and no one wins in that case. We need 2 cells for the 1 and the 4, and we don't have it anymore. So this can't be a 3 for that reason. So this is a 1, 4 pair, and you can see that we already have all these 1, 4s over here. So that didn't help the row, but it does restrict where the digits we removed can go in that box. So we'll think about that in a moment. Let's make sure we covered all the duplicates. We did the 2, we did the 8. By finding this stuff, we have reduced this column down to 3 remaining digits. You might say, well, this looks a whole lot like 5 to me. But remember, according to the column, it doesn't care how the 1, 4 resolves. We know where the 1, 4 go, basically. So these 3 cells are going to be the 3 digits unaccounted for. They're going to be the 3, the 4, and the 5. Now we know that neither of these can be 4. Oh, sorry, not 3, 4, 5. I misspoke. The 4 is down here. The 3, the 5, and the 7. Sorry about that. So 3, 5, 7. This cell can't be 7, so it's down to 3, 5. I'm going to mark that. I'm going to mark any cell that's down to 3 or fewer candidates. If it's 4 or more, I don't mark it. And these are both 3, 5, 7 as well, and they're down to 3, so I'll mark it, but they're not restricted beyond that. We also reduced this box down to 4. It's going to be the 3, 5, the 3, 5, 6, 7. So one thing I'm noticing is that because these 2 aren't 6, and these aren't 6, and these never were 6 actually, it puts the 6 in one of these 2 cells. And finally, we have pointing. We have useful pointing. So what is pointing? Well, remember claiming, it's kind of the opposite. In this box, we have determined that 6 is only in 2 cells, and those 2 cells share a row with each other. So according to this row, does it care which one of these ends up as 6? It does not. Is it possible for neither of these to end up as 6? It is not. We need a 6 in the box. So because the 6 in the box will end up in row 2, the other boxes cannot have a 6 in row 2. Importantly, that means these aren't 6. This 6 looks in saying these aren't 6. This 6 looks up saying that's not 6. And this 1 says that's not 6. So we now have a hidden single 6 in the box, which was informed by the fact that we couldn't have it in this row anymore because of the pointing. It's called pointing because you can kind of draw a line between these and think about like making an arrowhead out of that. And so it's pointing in the direction of the line and removing it from the rest of the row. So we can place this 6 here. We can follow up on that with the buddy 6s and this 6, placing this 6. Follow up on those. We get a 6 down here somewhere. Okay. Now there was more to follow up on. These were down to 3, 5, 6, 7. I do know that this can't be 7, so we can do 3, 5, 6. This can't be 5, so this is 3. It can't be 3 or 5, so this is only 6, 7. That can be helpful. Okay, so we had other things we placed that we wanted to follow up on. So for example, down here, we did place this 6. We filled this box row earlier. It's not going to be helpful. We already basically know how this box resolves, so we don't really need to worry about that strategy anymore for that box. But we did reduce this row down to 4 open cells, so let's think about that. We need the 3, 4, what did I miss? Oh, we need 2, 3, 4, and 8. So I'm looking for 2s, 3s, 4s, and 8s in this column and these columns. 2s, 3s, 4s, and 8s. So I'm seeing this sees a 3. So this is 2, 4, 8. Oh, it sees a 4 as well. Sorry, 3 and 4. This cell sees an 8. So it's 2, 3, 4. And this cell doesn't see any of those. So we're not going to mark it. This cell doesn't see any of them. Oh, it sees a 6. Oh, no, we don't care about 6. 2, 3, 4, 8 is what we care about. So yeah, these are both 2, 3, 4, 8. We're not going to bother marking them because that's 4 digits. Okay, so that was that row. Anything else in this band of note? This formation here is definitely worth thinking about. We may have done this a little bit later in the solve as well, but I think we're getting to the point where it's useful for sure to just be looking for stuff like this, which is, I noticed that these were all filled. So there's only 1 row and 1 column left in this box that hasn't been filled, 1 row and column. So you can look along those rows and columns for any digit that's not in the box yet. 1, 5, and 6 already in the box. 5, 6 already in the box. 3 is already in the box, but the 2 is not. So this 2 removes it from these 3 cells, and these are also all filled up. So actually the 2 is in one of these 2, and that causes pointing. These 2s point up, saying these can't be 2. This 2 looks up. This 2 looks in. So we end up with a 2 in one of these 2, which could come in handy for sure. All right, we also wanted to follow up on this band. This band is done with the follow-ups. So we filled this box row. So we want to look here for anything not already placed in the box. The 5, the 8 are already placed, but the 3 is not. And so what I want you to think about is 3 can't be in these 3 cells because they're filled with non-3s. Where would the 3 be in this row then that removed 3 from these 3, if there was one? Well, it would have to be in this box. It would have to be over here. And in fact, it would have to be this cell specifically because we have this 3 here, taking it out of this one. But ultimately it would be in this row, right? In this box, because this box already has one in this row. So this box can't have another one, and this row can't have another one. So it would be over here. It would have to be in the same row as this, and it can't be in this box because this box already has a 3 in it. So the 3 would end up over here. This 9 isn't it. This 3 isn't it. So it would actually end up exactly here. And then those 3s would buddy up, and they would put a 3 up here, right? If we're talking about our buddy system. Well, I'm going to say that this is actually all true. And one way I can prove that to you, there's a few ways to prove it. One way to prove that to you is this box needs a 3. Whenever we can do box-centric scanning, that's always, in my opinion, easier to think about because it's all localized to one piece of eyesight. Whereas a row, you kind of have to scan left to right. A column, you have to look up and down. It's a lot harder to localize what you're thinking about. So if you can do it via the box, I feel like that's always easier. So this 3 here looks in, saying these aren't 3. These are not 3 because they're filled with non-3s. This isn't a 3. So there is a 3 in one of these 2, and that is going to point. That's going to say 3s can't be here, and this 3 says 3s can't be here, and this 3 says not here. So the 2 places I said 3s would be, they actually are. And that does remove 3 as candidates from these 2 cells. So we can remove that. And that does mean 3 is in one of these 2 cells. You can do that through the buddy system or just by looking at our markings at which cells have 3. Okay, so we just got more information here. We got this 3, we got these corner mark 3s. Did that fill up, let's see, did that fill up any box rows? It did not. Do we have any other buddies? We got the 6 taking care of the 8s. I'm looking at the blue ones. The blue ones are helpful because those are ones we placed. Now we're looking for any rows or boxes down to 4 or fewer. We have a few of those. Let's start with the least open cells. So in this row, we're down to 3. What are they? Well, we have the 1. We need a 2, 4, and 7. So I'm just going to center mark that because 2, 4, 7 is few enough that we can just center mark it. But then we see that this 4 sees that one, so that can't actually be 4. And when we center mark, I should point out that we are supposed to, I have been for you, but we're supposed to be looking at the rows and the columns and the boxes to see if we have any matched up cells to find more naked pairs, naked triples. I haven't found any as we've gone. So this 1-4 was the last thing I found, I'm pretty sure. But yeah, if I see any, I will tell you that I see it, and I'm always scanning for it. The only way to see it is just to constantly be vigilant and scanning for it. Okay, so this box is also down to 4 digits. There are the 3, 4, 7, and 9. We know neither of these are 3, so they're down to 4, 7, 9. These can be 3, 4, 7, 9, and I don't see anything restricting that. And so we're not going to mark 3, 4, 7, 9 there. All right, no other rows or boxes are down to 4 or fewer, so we have finished following up on that. Did we finish this stack following up on that? Well, not quite. We do have 4 left in this column now. I think it's because we placed the 3. And so this is down to 1, 4, 5, 6. This can't be 6, so it's 1, 4, 5. This can't be 5, so it's 1, 4, 6. Nothing particularly useful so far with any of that. It will be useful eventually. All right, so I'm noticing that this row, we filled this 6 at some point. This row got reduced to 4 or fewer. I'm basically at the point where I think I've kind of finished my bands and my stacks, my initial pass on that. So the thing to look for is, did I miss any rows or columns or boxes that are down to 4 or fewer? If so, let's take care of them now. So that's what I'm doing at this point. So we are down to the 2, 3, 5, 7. I see this can't be 3 or 7, so this is down to 2, 5. This can't be 2 or 5, so it's down to 3, 7. I already knew it couldn't be 2, 5 because of these corner marks here, right? These corner marks are doing a lot of work for us, telling us that it can't be here. This corner mark 3 is telling us this can't be 3 as well. Remember the claiming? So if this can't be 2, 3, or 5, and the row can only have 2, 3, 5, 7, that means it's down to just 7. And this is what's called a naked single, where the naked single is probably the easiest thing to understand. This cell needs to have a digit in it, and the only digit that it's allowed to have is a 7, so I guess it's a 7. All right, that removes the 7 from here. As soon as we make this 3, 8 pair, I like to clean up the corner mark 3s, because the 3, 8 pair does the same thing and more. It removes, this 3, 8 pair removes the 8 from here. It's a naked 3, 8 pair. The 8's up here, so it's not here. We can place the 7. Alternatively, you could think about, where does the 7 go in the column now, and it can only go there. We removed this 7. These 7s look into here, putting a 7 in one of these two, and it cleans up this 7. Great, okay. Now I know this is going to be a triple for the box because it just needs 3 more digits. Very, very useful to fill. We need the 2, the 5, and the 9. So 2, 5, 9. This one's not 9. This one's not 2 because of these over here. I noticed this 7 also cleans up this 7. And now I'm noticing either this 2, 5 pair or that 3 in this row has only one place to be placed. So we can place that 3, and that gives us the 5. Now remember, this 3, 5 pair resolved because of the row, right? So that's why that's a 3. It's not because of the column or the box. That's a 3, that's a 5. So we're going to suddenly get a lot of cascades here. I'm going to follow the non-trivial red marks first. We remove this corner mark 5, which means there's only one place for 5 in the box, so I can place that 5 in this 2. Now this is a 9 because it can't be 2, 5 anymore, and now that makes that a 5. This is a 6 because it can't be a 5. This is a 7. Just notice our red marks are no longer possible, right? So we get the 7 here. If you're not using the red marks, you just need to kind of rescan the digits that you placed. The red marks just save us time here because these already are very long solves. All right, so that's not a 7. It places the 7 here. I'm noticing this is down to 3, 4, 9. And this one can't be 9, which means 9's in one of these two. We care about that at this point. All right, we've finished following up on the red marks. Now let's go back and look at the consequence of all these digits that we just placed. So for example, we do have these two 2's looking in, so that's a 2 in one of these two. In fact, this row is just down to 2, 3, 8 remaining. So I'm going to fill that. This can't be 3, this can't be 8. And this row is down to 3, 8, 9. That's not an 8. Okay. And we know the 9's one of these two, for what it's worth. All right, there's probably more just to follow up on in terms of rows, columns, boxes down to 4 or fewer. I like to look for the one that's down to the fewest because it's going to be the most useful. So this column is down to just 3 or 4, and this cell can't be 3. So this has to be the 4, and that's the 3. That cleans up this 3 here. So we have this 4, 9 pair. Also, this 4 resolves this 1, 4 pair, which is quite nice. This row is now down to 2. Again, I'm trying to find rows, columns, boxes that have the fewest open cells. This is down to 8, 9. We can fill that, and this can't be 9 because of the box. So that's the 8, that's the 9. This box is now down to 2 digits. We need the 2 and the 3. It's not resolved, but it is a pair. This 9 that we placed removes this 9, which places 9 in the box by a corner mark. And at this point, I'm just going to basically just finish the puzzle, it looks like. Just continuing the same techniques we've been doing. So this row is down to 1, 4, 6, 9. The only cell that can be 6 is this one in the row. So that's a hidden single 6. This is down to 1, 4 only, and the only place that can be 9 in the row is here. That's a 9, that's a 4. This can't be 4. 4 is reduced to these two, for what it's worth. This is 1, 2, 4, 5, but it can't be 4 or 5, so it's down to 1, 2. I suppose the column would have been easier. In some aspects, at least. This whole row, we need 1, 2, 5, 9. The only cell that can be 9 is here. This can't be 1, so it's down to 2, 5. Can't be 5 either, because of the box. So that's a 2. I just clicked the wrong number on my keypad. All right, that's 2, that's 1, that's 5, that's 4 and 2. We get the 7, 4, and 1. This can't be 4. Up here, we get the 1 and the 4 resolved. This column, we see this 2, 3 pair. That means there's going to be a hidden single digit here. It's the not the 5. I misscanned. It's the 7. We also see this 2, 8 pair, causing this to be whatever the column's missing. Looks like it's a 1. And this 2, 3 pair does remove 2 from here, making that an 8. This is going to be the missing digit, the 4. This is 2 or 3, but can't be 2. So that's 3, that's 2, that's 3, that's 2. We get the 3. I misclicked. All right, we get the 3, 2, and 8 here. We get the 3 and 8, and we're done. All right, pretty typical time for my medium solves because I take the time to explain everything as we go, as you could probably tell. So hopefully this was helpful. If you want to watch kind of a more fluid solve where I explain a little bit less and only the things that aren't explained in the medium, you can check out my New York Times hard solves as well. And the idea being the hard solves are more there for people who already understand these techniques, but maybe got stuck or maybe just want to learn, maybe want to watch me solve it. Whatever reason, they're there as well. So hope you enjoyed this. And if you did, then why not leave a like, subscribe, and a kind comment below.